Hi everyone, my name is Ante, and today I will dive into brand new RDK-X5. On my channel, as you already know, there are a lot of different reviews for different boards for computer vision, machine learning. I am trying to focus specifically on edge devices and mostly on some NPU-based board. And here it's exactly this case. According to the documentation, it has pretty powerful NPU with 10 TOPS. And actually price is pretty competitive, form factor is pretty nice, amount of peripheral devices is pretty nice, so seems legit. Let's start. This board is from D-Robotics, and actually for me it's a new platform, but they already had X3 version. It had a little bit different architecture than this one, but it seems like all software is pretty similar. It's basically the same model zoo, same repository, and so on. So let's dive in and let's start from my first impressions, board setup, and so on. This board is pretty standard, but I want to highlight a few interesting differences with this board. First of all, I used the vendor-provided system image. Maybe it's better to download system image from D-Robotics, but the seller who sent me the board, there was like guide of how to use, and there was link on a different fork of D-Robotics system. So I installed it, and I don't know if it's correct or not, because on this vendor-specific build, there is already pre-built ROS, Jupyter, a lot of stuff pre-installed, but maybe it's changed some system behavior, I don't know. Because one of the first problems, this board, when you connect this to your network, your router will not see it because it's generate its own static IP. So if you connect it to your PC directly, your PC will see this. If you connect it to your local network, no. So specifically for this image, there was only 3 ways to have access. It's SSH, it's direct connect with LAN cable, and of course it's like turn on your monitor through HDMI, which I did. And after this, you can configure your Wi-Fi and easily connect to this board. Overall, the documentation of flashing is correct, everything is working, no problems at all. Only one difference that I found, all NPU drivers, they are not pre-installed, even in some like version from vendors, you need to install them yourself. There is some mismatch with documentation in different places. In my opinion, the better documentation in the model zoo, but it's not full, so you need to jump between like documentation in wiki and the documentation in model zoo. Let's brief go through this NPU and its capabilities. This NPU support only int8 inference, which of course will limit you. I already mentioned a lot of time on my channel why it's not the great approach. So you need to think about how you will prepare your neural network. It's like post-quantization techniques or quantization over training, or maybe some different approaches like taking some models that are stable to quantization. Also, there is a lot of documentation with claims about LLM support. And there is some mentioned in official documentation. There is like, if you buy from some specific vendors, they even will provide you with links how to run LLM on such board. But in reality, even in documentation, they mention that no, there is no support of any LLMs on this board. So, and also they mentioned that it's a bad idea to run LLMs on NPUs, depending on NPU, of course. So they mentioned that if you need LLM, you need to run them through Ollama. And of course, if you're running your LLMs with Ollama, it's just basic CPU inference. So in my opinion, this board, it's not appropriate for LLMs. If you will go through the model zoo, there will be a lot of mentioning about some linguistic models. But when you go into this folder, you will find only two models, Yolo-world and Clip. None of them it's like fully linguistic model. Yes, they can work with some text, but it's not the general idea how are they working. What is more interesting, if you will check how they are working with this linguistic part, for Yolo-world there is just a list with pre-calculated embeddings for different words, and if you need like to run it with your specific text, you need to pre-calculate them yourself. They didn't even give you the script how to pre-calculate them. For Clip, the situation is a little bit better. They have some sample, but also like I can run Clip almost on any NPU, and as far as I understand, it's only CNN version. So of course, there is no support of modern networks with LLM. It's me from the future. Actually, they have a repo pretty new, so probably when I initially play with this board, there was no in documentation that allow you to run VLM models, but it's pretty raw because it's running them through ROS, through Llama CPP, and LLM part is on CPU, but for VLM part, they are running this on BPU unit. So at least formally, they have this ability, but I'm like doubt that it's like intuitive, that it's running VLA, and definitely it's not something you can play easily from Python. Let's speak a little bit about expert. And actually here the things is going hot because it's pretty interesting board. I spent some times with it, playing with different environments, found that in general, they are recommend to use ONNX or possible, like there was mentioned of Cafe, but like ONNX. If you will run your export from ONNX, you will find some interesting artifacts that something like JIT tracer. So basically, when you run in ONNX export, they export this model in PyTorch, and then from PyTorch, they export this into their representation. At this point, maybe I can use PyTorch directly, but no, the main inference and the main image doesn't provide PyTorch export pipeline. But if you go deeper in the documentation, there is a way how you can run PyTorch export. I didn't go through all this way. Also, they recommend like with PyTorch use quantization-aware training, and it's get a little bit rough, but there is a possibility to export with PyTorch. In my opinion, for such situation, it's better just to open source all your scripts for export, because they didn't open source it. They just give predefined binary in Docker container for export from ONNX, and they just give in the different container, there is a script, like there is a pip library for PyTorch. And between them, there is some difference. What I like about export, like finish with this ONNX part, what I like is pretty interesting and robust debugging information. It's pretty rare for such boards, but here you can find a lot of information what's going wrong in your during your expert. And it was pretty nice because documentation, in my opinion, is not like super direct. There is not a lot of samples of expert. So I even like use ChatGPT just to collect all the samples and try to combine them in the one sample that I could run for basic ResNet model. This sample didn't work, but with this debugging, it was pretty easy to export this sample and fix all problems. What I completely don't like about this export, ONNX version support is limited of version 11. And actually it's a problem because a lot of ONNX stuff is starting working from 12 version. Also I have like a hive of my models that I'm using for debug, and like a small amount of them lower than version 11. So you're better to degrade your ONNX model for easier and simpler version. So let's get a little bit deeper into infrastructure of how you should prepare your system, and maybe a little bit about this PyTorch expert. So they are providing two Docker containers. One of them is CPU, the second is GPU. In their definition, they are the same except this support. But in reality, in GPU container, you will have much more drivers, libraries, and support. So I recommend to use this GPU container if it's possible. For me, this GPU container did work quite good when I virtualized Linux through VSL2 on my Windows, so I just run it on different Linux machine and everything was okay. With this GPU container, you will have deep integration with PyTorch. Can check this example. I don't like this example. It's like about specifically quantization-aware training for some specific use case. It's definitely not like full documentation on it. So I didn't run it myself, but at least like all these libraries, they accessible. And the problem is that you just can't install this pip library without like on your system. You need to use this specific container, so you will be limited by this version of PyTorch, or you need like to try to experiment with this stuff. Another interesting part about different models, it's this part with application algorithms, where you can find a lot of neural networks that you couldn't find in Model Zoo. And the interesting part that there is no script to export them, no way to reproduce, but there is a stereo depth estimation network which can run on NPU chip, which is pretty nice. But there are so much issues with this solution that I'm like a little bit confused. The first significant issue is that it's available only to run through ROS. There is no Python example. Even it's hard to find neural network itself to export. Yes, there is some sample with training, but without the final file of this training. And the main issue that network they are using, it's StereoNet. Actually, it's a pretty old neural network, which is like maybe 7 years ago, which output pretty bad quality of the depth estimation. On my channel, there was a few videos with comparison different stereo depth estimation network. And for this one, it's really the only stereo depth estimation neural network that could run on some NPU units. But this quality is much worse than any other stereo depth estimation network. So of course, if it's possible, it's better to use UniNet depth estimation network, or for example, HeatNet depth estimation. This one is not very accurate, but maybe they optimize it because they have their own pipeline with training. They modified this network somehow because there are like 4 different versions. But all documentation is too weak about training. It's too weak about the whole model. There is no like PyTorch code, no ONNX file, and I'm a little bit confused about this network. So I'm not sure that this network will perform quite good. Also, among these algorithms, you can find some algorithms for optical flow estimation. I don't expect that it will work great, but yes, I need to admit that they tried to optimize this board for robots, but it's a little bit confusing from ML development perspective. So let's check inference speed of this board. And as a sample, I will use like super basic neural networks that I used millions times. And one of them, it will be ResNet 18, the second main Yolo-V5. Also, you can see some different timings. What I like about their expert, they actually not only expert in model and like giving the final inference code, they also benchmarking everything, and they also benchmarking like separately. Forward time of the model, pre-processing, some conversions. It's pretty nice. I really like this because it's always a question what you need to highlight in your experiments, because some boards, they encapsulate this part, some no. But in general, usually I'm trying to compare specifically this forward time. So you can check this small table for this specifically 2 networks that I pretty often use for different boards. And as you can see, it's a really nice and fast board. Yes, you can find some quicker boards, some specific settings. For example, for Rockchip 3588, you can use all 3 cores and it will be faster, but it will be more complex. But in general, I like this board from the speed component. And let's start from pros. Nice performance, nice price range for this performance. NPU. There is GPU, but I didn't test it like specifically for GPU inference or some pre-processing. So, but maybe it can give some additional performance. What is nice about expert and NPU? You also can fall back your layers for CPU from this NPU from unsupported layers. So actually, pretty nice support of different models. Declarization and modular toolchain for your development, it's also a nice thing. What I completely don't like, int 8 support, LLM not working. Export to toolchain is a little bit like rough, needs some experiments, so you need to support this. But in general, nice board. Let's wrap up. Nice cost-effective board. It can work for a lot of AI cases. It gives you pretty nice performance, a lot of peripheral infrastructures. Is it better than Rockchip? I don't know. It's interesting board. Maybe it's a little bit cheaper, a little bit less performant, a little bit easier than Rockchip 3588. So another option, which is pretty nice. For real production projects, maybe Rockchip is a little bit more solid to choose right now. If you just have this as an opportunity for your robot, well, maybe nice board. But again, I don't think that it's like specifically robotic board. Maybe they like optimize it for ROS, but I didn't taste this part. From AI perspective, it's almost the same board as other modern Chinese board. So thank you for watching. Hope this helps, and see you next time.